You're listening to the TES Maths Podcast with Craig Barton.
Hello, Happy New Year and welcome to episode 4 of the TES Maths Podcast with me, Craig Barton. Once again, we will bring you a jam-packed bundle of mathematically themed news, discussion and resources to get 2013 off to a flying start. Now, on the last episode, I said my guest would be Malcolm Swan. Unfortunately, Malcolm has not been well of late and so can't make it today, and we look forward to welcoming him on the podcast later in the year. However, all is not lost, as I am delighted to say that I am joined by Celia Hoyles, Director of the NCTM, that's the National Centre for Excellence in the Teaching of Mathematics, and she is also Professor of Maths Education at the Institution of Education. Welcome, Celia.
Thank you very much.
And thanks so much for joining us today. And we will be discussing the wonderful work of the NCTM and much, much more throughout the show. Just a reminder that you can find the links to all the resources and ideas mentioned during the episode on our website. That's www.tes.co.uk/mathspodcast. And if you're not already doing so, then please follow me on Twitter at TESMaths for daily resource recommendations and much more. And this recently included a countdown of the top 10 resources of 2012. Some absolute classics on there, all contributed by the kind, generous and ridiculously talented users of the TES Maths website. But with so much mathematical goodness to get through, we had best get cracking. For our news section this week, I want to take a look at the issue of numeracy across the curriculum. Now, this was featured in the most recent NCTM Secondary Magazine editorial post, and it was also a hotly debated topic in the TES Maths Forum. Now, in the NCTM article, they point out that in the Ofsted Inspection Handbook, there's a paragraph in there that states that judgments will be made on the consistent teaching of literacy and mathematics across the school. And they make the suggestion that teachers should go around with a video camera, filming history lessons and geography lessons that have good examples of mathematical practice in there. And then in the TES forum, there's a lovely little post of a lesson that a maths teacher planned for his history colleague called Hitler, a Miracle Worker. And this involves the students being given figures on German elections, unemployment, money circulation, and students use mathematical justifications to look at Hitler's rise to power, how it was sustained, voter turnout, etc. But I have a bit of a problem with this whole numeracy across the curriculum idea, and I want to get Celia's opinion on this, because if we take the Hitler example, is there a danger that just kind of planning contrived lessons like that, where it's almost shoehorning in a bit of mathematics, almost undermines the whole concept of numeracy across the curriculum? What's your take on it?
Well, I'd like to start, if I may, by just saying thank you very, very much for inviting me here.
Oh, our pleasure.
I'm really excited to be part of this TES Maths podcast. It obviously gets to lots of people and stirs people up a lot. And I think the numeracy or mathematics across the curriculum is something that, as you well know, has been hotly debated over many, many years, and it is difficult. And I think you've touched exactly on the main problem, that it can seem a little bit artificial. But maybe it's only artificial because it's not done very much. And I think the example that you quote about the history teacher and looking at data to justify an argument is something that's so important. And maybe we need some maybe sounding artificial case studies to begin with, to start people looking again through a new lens at that. Well, maybe I could look at it like this. I do think it's challenging, particularly in the secondary school, where on the whole subjects are quite compartmentalised.
Yes.
And they have to plan, and they have in mathematics we have very rather stringent assessment regimes, and so you have to make sure you get everything done. But if you can actually crack this and maybe start in the primary school, where there is much more cross-curricular work and project work, I think it could be enormously helpful.
But whose responsibility is it? If we take that history example, say that the students are calculating percentages and the history teacher isn't familiar with techniques for calculating percentage increase or ratio related things or something like that. Is it the maths teacher's responsibility to make sure the history department are trained up to that level of mathematical competence? And could you understand the history department saying we don't have time to do this, we've got a jam-packed curriculum that we need to get through, let us just concentrate on our history, you concentrate on the maths.
Yeah, I understand. It's so true, all the things you say. I think if it's a school priority, that this is something that should be done, and we're talking about maths across the curriculum rather than numeracy across the curriculum, but either way, then I would have thought it has to be the maths responsibility, somebody like an advanced skills teacher or a subject leader in the primary school who starts the conversation. And how can we use data, for example, following on your example, to justify an argument? And this is maybe looking at different representations of data, looking at graphs, looking at histograms, and looking at different frequency patterns and say, well, what does the data tell us about that particular argument? And then students will justify whatever argument they make on the basis of the history, what they know about history, but also bring in deliberately something about mathematics and numeracy, because all too often that last bit is not done.
Absolutely.
They'll talk about their opinions about reading a history article or knowing a little bit about this, and rather than use the maths. So I think it's something that is so important, if all right from the young age, all through primary and secondary school into university, if we can only get that more students see that bringing in a mathematical or quantitative argument is something that's crucial, I think we'll be doing an enormous favour to the whole population.
I agree, and see, I've been thinking long and hard about this, and I'm starting to lean towards the thought that it's better to have that taking part in a maths lesson than in, say, the history or geography lesson. I think it's easy for me as a maths teacher to take some data from geography or some data from history and look at that and process it mathematically than expect a history or geography teacher to do the mathematical processing within their lesson. So I think almost instead of imposing the maths in other lessons, it should be brought into the maths lesson. What would you think?
Yeah, well, I think I'm sure you would do it brilliantly, Craig, actually, in your maths lesson. And I think I actually have looked at research on this a few years ago, and there's rather little research, although there are lots of really good articles like the article you mentioned in the National Centre Secondary Magazine. But I do think the research seems to say that team teaching is the better.
Yes.
And it's understandable, it's very plausible, because although you'll do it brilliantly in the maths lesson, I do think it's an intertwining of, say, the historical argument with the mathematical argument. That's the crucial thing. So that when you're justifying or reasoning in work or in everyday life, you intertwine your mathematical views with what you know about the subject, whether it's law or geography or whatever. But what we know is it mustn't just be opinion. So I think this is an ideal world.
Yeah, that's right.
I'm talking about an ideal world, and I can see your face. This is not but I mean, maybe that's what people could do if they had professional development and they wanted, this was a priority in the school, that's what they should take a particular topic. And I wonder whether, rather than starting in the history lesson, it could start in the maths lesson, say, let's look at how percentages are used, or how we use different graphical representations, and that's the core, and then take the different subjects, because they all do use these sorts of arguments and different representations, and maybe that will be a way around it, but it probably has to be led by people like you, I think, to begin with.
And I think that,
or scientists, maybe.
Well, the science is something I'd like to come on to, because that's often the subject quoted as most closely associated with maths. But I've known classes that I've taught, and say I'm teaching them speed equals distance divided by time and looking at compound measures. Now, they've already covered that in science, or maybe density.
I know.
And they've been taught it a completely different way, and it might have a formula triangle, and they might cover up.
I know, the
and
triangle.
Exactly, and they don't know why they're covering it up, but they know it works. So then I'm faced with a really big dilemma there. Do I say, all right, that's fine to use in science, but in maths I want you to know why it works, and does that undermine what the science teacher's saying? Do I have to take a higher ground, say, no, this is maths, so this is what you do, and I want you to do this in science as well? It's a very tricky one. I don't want to undermine any colleagues, but at the same time, my students have to be doing things mathematically correct, and I don't want them using little tricks and gimmicks. And I've also known when rearranging science formula, because there's so many scientific formulas there, and it's great for students to practice substitution and rearranging formulas. But at the same time, I've seen things where when rearranging a formula, students are grabbing letters, putting a circle around them, chucking them to the other side of the equal sign. A plus is magically becoming a minus. They don't know why it's becoming a minus, but they've been taught that in another subject. And then I'm faced with the trouble of, do I have to undo that and teach them something else? Do I say, you can use that way in one subject and this way in another subject? And that's where I feel that this mathematics across the curriculum can often do more harm than good. And whose role is it there to... Does the schools need a consistent approach with it, that formulas are always taught this way, substitutions are always taught this way, whatever subject, graphs are always drawn this way? What do we do there?
Yeah.
So we just solved that problem.
No, I just solved this problem in a 5-minute conversation with you. That's easy. But I mean, it is the nature of mathematics that it has the structures, the reason why you do things, which is you as a maths teacher are passionate that students should understand why they put things on the other side and change the sign. But it's also the nature of mathematics that the machinery of mathematics is used to solve problems in lots of other subjects. Yes. And you do always have shortcuts. I know, for example, that after a while when you divide one fraction by the other, you take the second one and turn it upside down.
Sure.
Now, as a maths teacher, and I hope a science teacher, I could justify why I'm doing it. But you don't want to bother doing that.
No.
When you're actually on doing mathematics, you just do it. And I do think this is always the balance that has to be maintained in teaching maths, but teaching across the curriculum, between what you just do and what you have to understand. So in your problem, I think in an ideal world, you'll talk to the science people and you discuss a consistent approach. But if they have gone ahead and they've used their formula and their triangle and covering it up and all this sort of thing, I think you could maybe, I mean, you're the teacher, not me, you could discuss this with the students and say, in mathematics, we have to understand why we're doing things. That's what we're doing in maths. It's not just tricks.
Sure.
It's not just procedure. You have to know the procedures, like you're using in science or in geography or whatever. But our job here is to know why those procedures work. They're not just ad hoc. They work because there is mathematics there. And I think that's a crucial point, because if you're just doing a little trick and then you could just do another little trick and then who cares which trick you do. And I think the job of the mathematics teacher is to show that those tricks or those procedures there is a logic behind there that comes from the mathematical structures that underpin them.
Absolutely.
So maybe you could do it that way.
Sure.
But I'm a bit of a... I'm sure you know better than me.
Well,
I'm sure some of your listeners could say better than me.
I hope so. And just on that point, if you do have any thoughts on this, just remember we have a dedicated podcast thread for this particular episode. And if you want to share your thoughts on numeracy across the curriculum, responding to anything, or mathematics across the curriculum, responding to anything that myself and Celia have discussed, that would be the place to do it. So for Show and Tell this week, we take a look at another area of mathematics that many students struggle with, and that is the wonderful world of fractions. Now, when I did my PGCE assignment, I chose fractions misconceptions to do it on, and as a young teacher coming into the profession, I could not believe the amount of mistakes students were making with fractions. And when I really started to think about this, I came to the conclusion that fractions are an absolute nightmare for students, and even myself as a teacher, the more I thought about it, the more confused I was getting. One thing students were getting wrong was they were confusing whether fractions were actual quantities or were they numbers, were they quantities of amounts or actual physical numbers. So for example, 2/3, was that 2/3 of a pizza? Was it 2/3 of an amount of something, or was it 0.66666666? And 2/3 is a nice fraction of an amount, but it's an absolute horrendous decimal to deal with. So that was causing a problem. Then we have what I would consider to be one of the worst rules ever in mathematics, and that is whatever you do to the top of the fraction, do the same to the bottom. So you get classic thing here, students, I'll add 1 to the top and I'll add 1 to the bottom. Well, wait a minute, that doesn't work. Why doesn't it work? I've no idea. And it's, again, another nightmare for students to deal with. And then this caught my eye on the TES forum, and I've encountered this as well. A maths teacher called Phil Eden emailed in to say that one of his students had asked him this question. If I get 3 out of 10 in one test and 4 out of 10 in another test, then I've got 7 out of 20 in total. 3 plus 4 is 7, 10 plus 10 is 20. But of course 3 tenths plus 4 tenths isn't 7 20ths, it's 7 tenths. So then you've got that issue that sometimes you do have the tops and the bottoms, but sometimes you don't have the tops and the bottoms. So I've had a big think about this, about how we can deal with all these problems with fractions. But before I launch into a few ideas I've had, I just wanted to get Celia's take on this. Now, can you understand the problems students have with fractions?
I certainly could understand the problem. And actually, because you told me kindly a couple of days ago that this would be your area that you wanted to discuss, I did start thinking about fractions. I looked on our National Centre NCTM portal and looked at lots of stuff on fractions. There's brilliant stuff. And by the end of it, I thought, oh my goodness, I don't know, I'm getting more and more confused. Because the thing, it's not that I'm confused, sorry, but it is a complicated notion.
Yes.
You have to decide, as a teacher, what is a fraction, and is it a number, or is it a measure? There are all these different representations of fractions, as you well described. I mean, if you start beginning with division, and what does division mean? And then there's this whole notion of if you do 6 divided by 4, or 6 divided by 3, let's make it easier, is it grouping or is it sharing? Yes. And that starts, and then division, of course, is the inverse of multiplication. And then once you get to fractions, you then have to think of all the different ways you write them, and then you might have pictures of pizzas, and then it's that point on the number line. But to be honest, it's such a crucial area of mathematics, as you well know. I mean, a fraction is a rational number. We can't forget about them. There are an enormous number of them, and but it's recognising this complexity and thinking a way through as a teacher or as a group of teachers about trying to build those notions about what it is, what are the different representations, where does it appear, and then obviously you then have to think about equivalence of fractions.
Absolutely.
And that's, again, it can be illustrated beautifully. There are lots of nice manipulatives. And then once you've got that in place, you have a fighting chance to think about adding fractions. And that takes me back to your, 3 out of 10 and whatever. Because we have to say, well, what is a fraction? And then we have to say we only actually add or subtract equivalent fractions. So I think there is a progression that is quite well defined, although there are different ways of going through those progressions, about what it is, what are equivalents, what are the different representations, what are the different activities.
Well, that's funny you should say that, because that's exactly what my department's doing this Wednesday, actually, coming up. We do this once a month where we pick a topic and we each bring in ideas and discuss it. So I thought I'd tie it in to kind of halve my workload. Seeing I was thinking about fractions for the podcast, I'd choose that as the topic for the department. So I've got 3 ideas that I'd just like to run by you, Celia, and see if you like these. Feel free to tear them apart.
Oh no, I won't.
So if I am trying to convince my students when adding fractions that they can't simply add the tops and the bottoms together,
right,
I'll do something simple like this. So I'll ask them what's bigger, 1/3 or 1/4, and give them 5 minutes to discuss that. And most students, whether they think of it in terms of pizzas, cakes, amounts of money or whatever, can come to the conclusion that 1/3 is bigger than 1/4. So once we've established that fact beyond doubt, I then write on the board, okay, 1/3 plus 1/5 equals what? So 1/3 plus 1/5. And the vast majority of students, if they've not been taught adding fractions, or even if they have in some cases, will simply write down that is 2/8. Add the tops, add the bottoms. And then I'll say, okay, 2/8, can we write that in any other way? And again, most students will be happy reducing 2/8 to 1/4. And then I pause there and say, can anybody spot any problem with that at all, or are we happy with that? And after a little bit of prompting, and especially if I draw a little circle around the 1/3 and the little circle over the 1/4, students will realise that, well, wait a minute, we've started off with 1/3, which we know is bigger than 1/4. We've added something to it, and yet we're claiming we've got an answer that's smaller. So 1/3 plus something has ended up with an answer that's smaller. And I think, whilst that doesn't teach students how to add fractions, I think it's so important, and we've talked about this previously on the podcast, that students realise that a method is wrong, once they can convince themselves that something is wrong, then they're more open to looking for a better or a more accurate way of doing it, a more correct way of doing it. Me just telling students you can't add tops and bottoms together, well, how can they be convinced by that? Well, why can't we, sir? But if I can show them and demonstrate to them in a way that they can understand that they can't simply do that, I think they're more receptive to it. So that would be how I would perhaps try and convince students that they can't add tops and bottoms. Would that convince you?
Yeah, I think that's brilliant. I think because you're saying you have underlying mathematics, there is a consistency. And you said, I think you said a third and a quarter, and you decided together which was bigger, and then you've gone through their procedure and you come up with completely the opposite. And I think that's a wonderful mathematical process, apart from the fact it helps them realise that this is the wrong procedure.
Yes.
And I think there are other things that you can do similarly, where you can take two fractions and you add them and you get the same on the top and the same on the bottom, and suddenly you get one.
Exactly.
And you think, hang on, that's not one.
That's nice.
But it's the same idea, that they will come to the conclusion that their process or their procedure is incorrect. And as you rightly said, Craig, it doesn't tell them what the right procedure is. And maybe you've taught the right procedure, or maybe you return to the right procedure of looking at equivalent fractions. But at least they might have had a memorable experience.
That's right.
I remember sir saying, oh God, and we got this completely silly answer. And I think that's exactly how maths should be taught. So you come up short, and over again you think, oh goodness, that can't be the case.
That's right.
And so I have to rethink my process, and that's when you need teachers to help you rethink your process.
Yes.
Because they're not going to find the correct method, probably, without going through some sort of teaching or teaching sequence.
Absolutely right. Well, so that one's gone down quite well.
Yeah, very good.
But what about this? I think this might
I'm learning lots.
No, I think this might be a bit more controversial, and I can't make my mind up about this one. I saw this. It was actually a TES article back in 2002 by Peter Critchley, and it's quoted on the Emmerich website. And he describes a primary school teacher carrying out this lesson. So with her students, I think they were year 5 students, wrote on the board 2/3 and 3/4 and challenged the students to decide which one was bigger. And apparently the teacher had got the class to such a level where they were used to kind of just going off and studying things independently. So what is bigger, 2/3 or 3/4? They could use any mathematical apparatus available to them. So some were using bits of paper, some were using strings, some were getting money out, all this kind of stuff. They had half an hour to discuss it between them, and then the teacher collected all their ideas together on the board. And via several different methods, the class came to the conclusion that indeed 3/4 was bigger than 2/3. Now, there was apparently 5 minutes left in the lesson when the teacher decided to do this. Now, I'll have to try and describe this as best I can, because obviously this is an audio podcast. But the teacher drew a really big circle on the board and a really small circle on the board. And on the really small circle, she shaded 3/4 of it in. And on the really big circle, she shaded 2/3 of it in. And then said to the students, but surely 2/3 is bigger than 3/4. Have a think about it for homework. Now, part of me says that's brilliant. The other part of me says those kids are coming out of that lesson thinking, what on earth has gone on? I don't understand fractions. What's your take on something like that kind of teaching technique?
But that's not the end of the story, presumably. She sent them away to think about it, and they came back, and then presumably they would have all discussed what they thought, and they said, "Oh my God, we're completely confused."
But how would you explain that?
Well, it's the whole idea of fractions being a part of a whole, and what the whole is, isn't it? And that, I think she's raising that to, the point of attention is it's a fraction of a whole in this particular case, rather than a fraction being a number, which is what she was talking about before, where you have it on the number line.
But that's so confusing, isn't it? So then if students see a fraction, is it a number or is it a part of a whole?
Well, it's both. That's the trouble. I mean, I don't know whether, and also you can change it to a decimal, and you can, use your calculator, do lots of other things as well. There are lots of different ways of doing it. But in a way, it's up to teachers to decide, in a way, whether the class as a whole is ready for this shock, where they thought they got it. But I think learning maths, if I think back at my history, I always thought I was okay, and then I had a shock. I thought I understood that. I thought, oh my goodness. Because you move to another way of thinking about things, and fractions, as we said, right at the beginning, has different uses and different
Sure.
things. And so I like it, but I think she would have judged that was okay for her students.
Sure.
And then when the students came back, they could have a really good discussion about it.
And the final one is one of my all-time favourites, this. And again, I think it was inspired actually by that same article by Peter Critchley, but NRICH have taken it on one step further. And I've done this with teachers and students, and it's gone down really well. And that's where you get 3 tables, and on table 1, you put a 1 Mars bar. On table 2, you put 2 Mars bars. And on table 3, you put 3 Mars bars. Other chocolate products are available. I'll have to be careful not to product place there. And you say to the students, OK, student 1, I want you to go and sit at the table that will get you the most chocolate. So student 1 wanders up and sits at the table with 3 Mars bars. And he's laughing, thinking I'm getting my hands on 3 Mars bars here. Say student 2, OK? You now go and sit at the table where you think you're going to get the most.
Interesting.
So student 2 stands up, has a look, thinks I'm going to get 1 Mars bar there, I'm going to get 2 all to myself there, I'm going to have to split those 3 between 2 people if I sit with him, so probably goes and sits on table 2. Now you can see where this is going,
Yes.
and it gets to a fascinating point where by the time the 7th student stands up, he's faced with a choice between either joining table 1, table 2 or table 3. And in fact, he's actually faced with the choice of deciding whether it's better to have half, 2/3 or 3/4. So then you've got students have now, I think it's so important to give students an incentive to figure something out. And what better incentive than a bit of chocolate? So students have got to decide which of those 3 fractions is better, what's going to get them more chocolate. And the NRICH talks about different strategies used involving bits of paper, making mock chocolate bars up with 12 pieces in them and sharing out those 12 pieces. An interesting one was actually converting those fractions to time intervals, so half an hour, 2/3 of an hour, 3/4 of an hour to decide that way. But what I love about that is it's just such a different way of looking at it. It's an exciting way. It's a challenge for the students, and you can differentiate it because with some classes, it will be enough to figure out where the first 6 people sit. But then as soon as you bring that 7th in, you've got a whole different ball game. And if you really want to push students on, say, OK, we've got a class of 30 students here. You tell me where each of those 30 people are going to sit. And can you come up with any quick strategies for doing it? And NRICH have got a nice interactive version of this problem on their website. But I like doing it the old-fashioned way there. Buy yourself 6 bars of chocolate, 1, 2 there, 3 there. And just let this roll. Now, what do you? A bit of a leading question here, and I'll be devastated if you don't like this because it's one of my all-time favourites.
Oh, I think it's awful.
Let's end the show there.
No, I think it's brilliant. I do actually think, I don't know that particular, and thank you very much for drawing that to my attention. I think it's really interesting. And I think what's so great about it is there's lots of different ways of taking it.
Absolutely.
And it will be up to the teacher to think about how much effort and time they can spend. I mean, with so much mathematics, you can spend ages on what looks like a simple problem. But in fact, actually, it's got so many spin-offs. And as you say, I can imagine it's very motivating.
Yeah.
And I think you've raised something quite interesting, too, at the end, about whether it could be done with real chocolate or with on interactive. And it's an interesting dilemma that we all have to make decisions about, because there are advantages of some.
Absolutely.
Obviously, if it's on the computer, you can do the cutting much more easily and shift about, manipulate, and keep a trace of what you've done. But there's something rather alluring about having real chocolate as well.
Absolutely.
And that's why teaching is such an interesting thing. But it's a brilliant activity, and I certainly will look it up and make sure I do something with it.
That's fantastic. And just to let people know that links to all the resources and ideas we discussed, including the ones from TES, NRICH and Celia's suggestions, will be available on our podcast page. And that concludes Show and Tell for this week. So we reach the part of the show now where I have the great pleasure of interviewing my guest. So Celia, can I ask you, what were your favourite and least favourite mathematics topics at school?
I think actually my favourite topic was understanding number and then moving into algebra. I'm a bit of an algebraist. I like symbols.
Me too.
And I think I really like that because ultimately I believe I'm a bit of a lazy person in mathematics, and I think a lot of mathematicians are. We don't like doing stuff and what we like is a nice shortcut. And I think the whole beauty of algebra is it gives you a shortcut. and you understand what it's about, and this rather beautiful system that we've got. And I think that actually enjoyment of mathematics in algebra continued when I studied mathematics at university. I just like the idea of the structure of numbers and understanding why they did what they did, and inverse operations and groups and all that sort of stuff. So I think that's always been my favourite. It's sort of somehow a nice, clean idea, but it also helped you. I wasn't that keen on doing all the calculations.
No, saves you a bit of time. How about least favourite?
I think I found this. I do remember doing lots of Durell combinatorics.
Oh, geez.
And I just found, and it is a different way of reasoning, and I've actually come to really enjoy it, and I recognise it's incredibly important, not only for mathematicians and statisticians, but for everyday life. We've got to think probabilistically,
yes,
because life's not deterministic in the way that we would like it to be. So I think I've learnt to know and love it. But when I do remember at school, and I think it shows my age, doing those combinatorics, perms and coms, and getting myself, and probability. And I remember teaching myself, Celia, do not trust your intuitions.
Yes.
Because your intuitions will always be wrong. And then what you have to do is you have to step back, don't think intuitively, and think, well, that's the way I do it symbolically. So I write the probability formula or whatever, and then I'd sort of get it there that way. Otherwise, I always got these things wrong. And I remember it very clearly. So when I think of sort of a story of not liking it, but then learning to realise the power of this thinking.
Sounds perfect. Sounds very good. And if someone had never heard of the NCTM at all, how would you describe what it does and what its function is?
Well, I think its function is twofold. I think the NCTM still has a very important function of raising the profile of professional learning for maths teachers. So it is, in a way, it's a publicity thing and it's a policy thing. And I think we've had quite a bit of success in, with the civil servants and with ministers, that this is important. We cannot neglect mathematics teachers. They are crucial. You can change the curriculum and assessment, but ultimately it's the teachers and the students and the teacher-student interaction that's important. And then I think the other side is, as we mentioned, there's a lot of professional development resources on our portal that we have developed ourselves, or our teachers have developed, and we monitor. And we also hope that our portal is a window onto other areas.
And that's fantastic. And has the role of the NCTM changed with the recent changes, with the reduction of the local authorities and consultants kind of disappearing and ASTs disappearing? Has the NCTM almost had to step up and fill the gap left by that?
Well, we can't. I mean, it's a big gap. I don't know whether ASTs have disappeared.
No,
I very much hope not.
Well, so do I, but I keep hearing worrying things. But,
yeah. I mean, we worked a lot, and maybe you know this, with ASTs, because on the whole, we would be brokering relationships between, the subject leaders, whether they're the maths specialists in the primary school or the ASTs in the secondary school, and try and support them. As in turn, we cannot obviously take the place of all the local authority support. But what we want to do is try and broker relationships with other sorts of networks. And we work a lot with teaching schools now, which is a government priority.
Sure.
And then maths lead teaching schools. Often it's, the brilliant people we've known before who are coming in these roles and supporting them. So yes, it has changed, maybe more challenging in many ways. But I hope that we can point subject leaders and heads of department to good stuff so that they can do it themselves. Because I think we all need to have an injection of an exciting new idea, but then ultimately you have to work together.
And could you give us an example of some of the projects that you've kind of commissioned in the past? And
there's about 360 if you take the time of the National Centre. But we've taken some that are around technology. How are you using this particular technology? Could be in the older children, or could be in the younger children. We've got how do you use ideas about good questioning, which is something that keeps coming up.
Absolutely.
And the fact it keeps coming up, I don't think is a failure. I think everybody a group of teachers has to rethink it themselves.
That's right.
We hope that they will learn from the other groups of teachers that have said how do you ask open-ended questions. But I do think it's something that you have to do yourself, with your colleagues. And then gradually it's like a sort of spiral curriculum.
Absolutely. I mean, for me, questioning is the single most important thing that a teacher can develop. I just want to discuss this briefly. You mentioned there kind of the government emphasis on teaching skills. I mean, I in no way want to get bogged down in the politics of things, but I've actually had a question from on Twitter by a friend of the podcast, Peter Rowlett, who is just interested on your views on Gove's, just his plans for education, the direction that maths education seems to be going. Do you think is it going the right way? What emphasis should we be putting on things? I'm thinking along the lines of the EBAC. I'm thinking of the plans for almost a real-life post-16 maths qualification. I'm thinking about the use of technology in classrooms, looking to develop the maths curriculum by making international comparisons with Singapore, all that kind of thing. Which of those areas do you think are the right ones to be focusing on, and are there any that you think, oh no, I don't think that should be where we should be putting our emphasis?
That's pretty big.
Oh no, yeah.
So where shall I shall take the opportunity of picking the ones that I like.
Let's do that. Right. That's no problem.
I do actually think anything to do with teaching and learning mathematics and enhancing mathematics learning through technology. I'm not quite sure if this is Michael Gove's priority, but I know that Liz Truss, the Minister, is interested in this. And I am passionate about that because I do think there's some wonderful opportunities for students to engage with mathematics in the way we've talked about in this conversation through technology. It's not replacing teachers, it's enhancing the conversation, because you get some feedback from the technology and then you say, well, how do we get that? And we talk about it. And I could like to give a plug for the National Centre in that on February the 27th, we do have a big event about digital technologies and maths where a lot of people, teachers are going to discuss together what they have done, and also there will be workshops with different software. And this, for me, is something that's so important. And I think, although it's used wonderfully in some classrooms, I think it maybe could be used a little bit more.
Oh, now let me pick you up on something there, because this is probably one of the most common questions I get asked on Twitter is, what's the best app I can be using for maths in my classroom? And the amount of stories I've heard of schools buying bucket loads of iPads, chucking them into the classroom and hoping magically that learning is going to improve. Now, you said that, I think you said that you'd like technology to be used more. What for you is effective use of technology in a maths classroom? Where have you seen it being used where it really has enhanced teaching and learning?
Well, I'll start by your story about all these iPads and tablets that are going into class. I mean, if you look at the history of technology in maths, but more generally, which I certainly have, it always follows that pattern. You get the technology, whether it was the laptop, and then you think, what on earth am I going to do with it? And that is really the wrong way going about it.
Yes.
So I think you have to, and this is what teachers are doing and we are doing in our university, is thinking about what could the digital technology do to really enhance mathematics. You talked about misconceptions. Well, how could the students see by visually, dynamically, by manipulating things, what their misconception is, where they've got it wrong. And there are lots of technology that does that. So I think it's the wrong way down, in a way. So I would like to say, well, what can we really think the potential of technology? So it's not just doing the same thing, because it's too much of a hassle and it's expensive and it's silly, but doing something that we know is hard and we can make it better. Like, for example, bits of algebra. It can really be enhanced by you're working in the particular and you can see the general by moving things around.
Another question from Twitter, actually, and this goes back to what I was saying about the direction that education's going. This is from @RuPresents on Twitter, and he's asked Celia, do functional skills provide young people with enough confidence in their maths ability? And I guess this links into what we were saying about the MEI seem to be working on this post-16 qualification that's more functional skills and problem solving, moving away from perhaps the algebraic and more abstract maths A level. So what's your view on functional skills? Have we got it right at the moment?
Well, my view about mathematics being functional, in that you look at applications, is that it's really important. I mean, I think we know there's pure maths and applied maths, there has been forever. And I think to actually make sure that students are able to think mathematically and use mathematics as a tool to solve problems, which I think is the aspiration of functional skills and probably the aspiration of the post-16 maths initiative, is that you have a problem, you have a situation, what mathematics can I draw on to solve that? And that is a crucial and difficult thing to do. And I think to have any initiatives that encourage students to do that, not just to follow the exercises in their books, but actually to use mathematics functionally in a way. Whether that has been successful in curriculum development, I don't know, I'm not the person to ask. But the aspiration is crucial, that we as mathematicians and maths teachers have to be aware that mathematics is used. And when you go out in the workplace, I've done some research on maths in the workplace, maths is used all the time in the workplace, and it doesn't happen magically.
Just a couple more questions, if that's all right. Now, I don't know if this is perhaps breaking news, if you haven't seen it on the NCTM homepage, but you're actually stepping down from your role as director in March. What does this mean for the future of the NCTM? Will it carry on in the same direction? What will you be doing? What will the NCTM be doing?
Well, yes, I've been doing it since 2007, and I thought now is the time, and I will be stepping down at the end of March. And I will actually keep some connection there, particularly in sort of some advisory role if I'm wanted, because I feel very passionate about the future. But I'm delighted to also announce that we have a new director. I mean, it's not the end by a long, long way. I very much hope not. And the new director is Charlie Stripp, who is Chief Executive of MEI, who, as you said, fantastic. He's somebody who's very well known in the maths community. Now, whether it will be the same direction, I don't know. I mean, as a new director, he will have his own priorities. But we are a government contract, and so obviously we are shaped by what the government wants. But knowing Charlie and knowing how good he is, I think the fundamental core ideas of what the National Centre is doing, which is supporting professional learnings and maths teachers, I absolutely know that he will continue doing this. So I shall return to my research and teaching, and I shall, support the National Centre in every way I can, but more from the outside than the in.
Oh, fantastic. Well, let me just say once again, thank you so much for joining us today, Celia. I've had a great time. Thank you very much.
Thank you for asking me.
Well, we've reached that time of the episode where I like to challenge you with a podcast puzzle. Now, this is one that I gave to my Year 11 class just the other day, and it really got them thinking. So I thought I'd share it with you, and perhaps you want to have a think about it yourself and then maybe even share it with your students. And this comes from one of my favourite books by Martin Gardner, an absolute genius when it comes to intriguing maths problems. And the puzzle goes like this. There's a plane that travels 1,000 miles to a destination and then 1,000 miles back, and it travels at an average speed of 200 miles an hour. Now, the first time this plane does this journey, there's no wind at all. So it travels at 1,000 miles there and 1,000 miles back at 200 miles an hour. The second time this plane does this round trip, there's actually a 50-mile-an-hour wind blowing in the direction that the plane is travelling on the way there. But then, of course, when the plane travels back, that 50-mile-an-hour wind is blowing against the plane. So my question there is, which journey is quicker, or do they both take the exact same time? Now, just try this with your students. There's a lovely bit of maths involved. It's counterintuitive, and it's mathematics that can be solved by Year 9 students, Year 8 students, anyone who's done anything with speed, distance, time. So that is this month's podcast puzzle, courtesy of the wonderful Martin Gardner. So we've reached the end of yet another podcast. Just a reminder that you can find the links to all the resources and ideas mentioned on this episode on our website, and that is www.tes.co.uk/mathspodcast. And also please check out my Twitter feed, which is @TESmaths, for daily resource recommendations and much more. All that's left for me to do is once again thank Celia Hoyle so much for joining us. It's been an absolute pleasure. Thanks everybody for listening, take care, and I will see you next episode. Bye for now.